Hello everyone. On this video we will look at how to determine significant digits, precision, and accuracy. It's pretty similar to rounding numbers, but it has a different set of rules. Okay, so here are your rules for finding the significant digits. Okay, first, non-zero digits are always significant. If you have a 1, a 2, a 5, a 7, doesn't matter. 1 through 9 are always significant. Now, when it comes to zeros, that's a different story, because you have some situations where a zero is significant and some situations where they aren't. Okay, now a zero is significant when it appears between two significant digits. So you remember, non-zero digits are always significant. So for example, if you have 2005, the 2 and the 5 are significant. So if the zeros appear between them, they're significant also. So 2005 has 4 significant digits. Okay. Second, it is at the right end of a decimal. So if you have 32.0, that 0 is counted as a significant digit. So 32.0 has 3 significant digits. You have the 2 non-zero digits and the 0 to the right of the decimal. Okay. C is when it's marked as a significant digit, and that's usually when it has the over bar. Okay, so you have 370, but that 0 has the over bar, has 3 significant digits. Okay, now a 0 is not significant. If you're still writing this, I'm just going to scoot it up a little bit. Okay, a 0 is not significant when it is at the right end of a whole number. So, for example, if you have 370 with no overbar, it has 2 significant digits. If you have 370 with the overbar over the 0, it's significant. But just 370 by itself with no bar, it's not counted as significant. So here you have just 2 significant digits. And the other time zeros aren't significant is when it's at the left end of a number. Okay, so if you have 0.063, you're at the left end of the significant digits. So those 2 zeros are not significant. So 0.063 has 2 significant digits. Okay, I know there are a lot of rules to remember, but a little bit of practice and a little bit of memorization for these, hopefully it'll kind of make sense. All right, so if you are still writing these, which you should be writing these down, please feel free to press pause and finish up. But we're going to go ahead and move on to a couple of examples. All right, so we're going to determine the number of significant digits in each of the measurements. We have 2.05 pounds, 22,000 miles, 13,700 gallons. Remember, the zero is over the middle. The bar is over the middle zero. 0.007 volts, or 7 thousandths, or 100.0 ounces. All right, so we're going to go ahead and do problem A. Okay, you have 2.05 pounds. Okay, what we see here, you have your non-zero, 2 and 5, so those 2 are significant. And you have the 0 in between 2 significant digits, which makes that significant. Okay, so this has 3 significant digits. And I'm just going to write that for significant instead of writing significant over and over and over. 3 significant digits because the 0 is between 2 non-zero digits. Okay, so remember, when you have two non-zero digits, any non-zero digits are automatically significant. But if you have a zero between those non-zero digits, then that's also significant. All right, so what I want you to do is for B, C, D, and E, I want you to press pause and try to solve those using the rules for significant digits on the previous page. All right, so I'm assuming you've paused it and you've solved B through E. So let's go ahead and verify those. Okay, so let's look at problem B. We have 22,000 miles. Okay, so we see there that 22,000 miles only has two significant digits. All right, and that's the 2 and the 2. Why? It's because the zeros are not significant since they are on the right end of a whole number. All right, so each of them are all of those rules are pretty specific. It just takes a little bit of practice. Okay, so for problem C, you have 13,700 and the bar is over the middle zero. Okay, so here we see we have 4 significant digits. Okay, so why? Because you have your non-zero digits, which are significant, and you have the 0 with the bar over it, which is significant. Remember, the 0 at the right end of a whole number is not significant. Non-zero digits and 0 with the bar are significant. The 0 at the right end is not. All right, so let's look at D. 0.007 volts. Okay, as you can see, it's just one significant digit. One significant digit. Okay. Why? Because you have these zeros, which are all on the left end of the number. So they are not significant. They are not significant. Okay, and we have E. Okay, you have 100.0 ounces. Now, instead of ounces, I'll just write OZ. Okay, now this one may be a little bit tricky. Hopefully, most of you did get this, but this one has 4 significant digits. Okay, why is that? Because if you think about it, remember, the values at the right end of the decimal are significant. Okay, remember, I'm going to block this just for a second. But go back to the previous sheet. If at the right end of a decimal, the 0 is significant. So that means this 0 here is significant. And also, any non-zero digits are significant. Plus, so since this is significant, and this is significant, any zeros in between two significant digits are also significant. I know it's a little bit tricky, but it takes a little bit of practice. Okay. Since the non-zero digit, which is the 1, and the decimal digit is significant, the zeros in between them are also significant. Uh-oh. All right. So again, it takes a little bit of practice. All right. So if you are still writing this, of course, feel free to press pause, but we're going to go ahead and move over to our next portion, which covers precision and accuracy. Okay. Now, precision is just a measurement that is indicated by the place value of the rightmost significant digit. So whatever place value the significant digit to the furthest right is, that's your precision. And your accuracy is just the number of significant digits. So let me go back to the previous page just for a second. Everything we did here gave us the accuracy. Okay, so this is accurate to 3 significant digits. This is accurate to 2 significant digits. This is accurate to 4 significant digits. This is accurate to 1 significant digit. This is accurate to 4 significant digits. So we already know how to do the accuracy. The accuracy is just the number of significant digits. All right, and the precision is just the significant digit place value to the rightmost digit. All right, so if you're writing this, feel free to press pause, but we're going to go ahead and do a couple of examples of precision and accuracy. All right, so state the precision and accuracy of the measurements. So you have 0.005 feet, or 5/1000ths of a foot. You have 180 volts. You have 21,000 tons with the bar over the first 0. And you have 0.08 of a second, or 0.80. All right, so let's go ahead and look at the first one. You have, let's look at A. Let me write the A there. You have 0.005 feet. Okay, so if we look at it for our precision, we have to find the place value of the rightmost significant digit. So none of those zeros are significant, but the 5 is significant, and it's the one furthest to the right. So it's the 10th, 100th, 1000th position. So it's precise to the nearest thousandths of a foot. Okay, so that's our precision. And how many significant digits do we have? Well, we only have 1 significant digit. So that means it's accurate to one significant digit. All right. So for B, C, and D, you probably know where I'm going with this. I want you to press pause and try to solve those on your own, just like this one. All right, so assuming you've paused it and you've worked this one out, so let's go ahead and verify. So for problem B, you have 180 volts. Okay, so you see here, remember this 0 right here is at the right of a whole number. So it's not significant. So that means the 1 and the 8 are the only two significant digits. So what's the place value of the 8? Since it's the significant digit to the furthest right, let's go ahead and point to that. It's precise. That's in the tens position, not tenths, tens position. So this is precise to the nearest 10 volts. And since we only have the two significant digits, accurate to two significant digits. All right, so I don't think that was too painful. Again, like I said, it takes practice because these can get kind of tricky. So just a little bit of practice. If you have to, rewrite these examples and after we're done and go over them again to see if you can solve each of them without looking at the answers. That will help you. Go back to the previous examples, do those again just to see if you can do them without looking at the answers. Again, the more you practice, even if you already know it, you still can go back and get a little bit of extra practice on these just by redoing the examples. It helps a lot. Okay, so for C, you have 21,000 tons with a bar over the first 0. So we see here that these two are the zeros to the far right of a whole number. Okay, so we see here that those two are not significant. The non-zero digits are, and the 0 with the bar are significant. So we're just going to underline those. Okay, so where's the place value of the significant digit to the furthest right? Well, that's in the hundreds spot. So when you have a whole number, you have ones, tens, hundreds. So you have hundreds. Okay, so since we're going to that spot, it's precise to the nearest 100 tons. Okay, how many significant digits do we have? Well, we have 3. So of course, it's accurate to 3 significant digits. All right, and let's do one more. That's our D, 0.80 seconds. Okay, so you see here that your decimal zeros are significant and your non-zero. Okay, so you have your 10th and you have your 100th position. And since this 0 is significant, precise to the nearest 100th second. Okay, And we see this 0 here to the left of the decimal is not significant. So this is accurate to 2, I'll just write the number 2, significant digits. All right. So once again, it just takes practice. I know this can seem a little bit confusing. A lot of this is confusing when you're just getting introduced to it. But try redoing the example problem. Like I said, even if you already know the answer, try just writing down the example on another sheet of paper and just put the answers away and try to solve them again, just without looking at the answers. Look at your sheet because you still want to get practice on using your significant digit rules and the definition of precision and the definition of accuracy. You want those. You have to memorize those. But once you get some practice in with the rules of significant digits, it will come kind of second nature if you do it enough times. All right. So hopefully this made sense, and I'll see you on the next video.